So dear students, welcome back for the numerical part with respect to a solution chapter, that is the numericals problems related to the physical concept in the form of which one? The solutions. So while solving this particular numericals, as if we know that it is restricted with respect to the liquid solutions, means those liquid solutions are of three types in the form of solid liquid solutions, liquid liquid solutions, and then the gas liquid solutions. That you have to be very familiar first. Means solid solute in a liquid solvent, that refers to the solid liquid solution. Preferably we are having the main in the form of colligative properties called as lowering of vapor pressure, elevation of boiling point, depression of freezing point, and finally the which pressure? Osmotic pressure. The second thing is the solution of a liquid solute in a liquid solvent is called as liquid liquid solution. So there we have to apply the Raoult's law of liquid mixtures, preferably the P1 or PA is equal to PA naught into X and PB is equal to PB naught into XB. So that you have to be very familiar if it is a liquid liquid solution. Okay. Suppose if it is the gas liquid solutions, what is that? Gas liquid solutions means the gaseous solute in a liquid solvent. We have to apply the what law here? The Henry's law, that is P is equal to usually KH into X, that is the only formula we are having with respect to the Henry's law. Okay. So that mole fraction that we can express that in the form of either the solubility also. We can have the mass in terms of mass may be given, or directly they may be given in the form of which one? The solubility. Okay, that is the first part. Then the second part is about the numerical formulas, or what are the various mathematical expressions related to this particular. Okay. So before knowing that particular expressions, you have to be very well versed with the symbols that has been strictly used in this particular chapter. Means, suppose if it is W means, W refers to which one? Mass. That you have to be very familiar. If it is M means, it is called as molecular mass or molar mass also. Molecular mass or molar mass. N refers to number of moles. N refers to which one? Number of moles. X refers to mole fraction. What fraction here? Mole fraction. So in this particular chapter, P is now regarded as the vapor pressure. It is not the ordinary pressure, it is the vapor pressure. Suppose if it is small p, it is called as partial pressure or partial vapor pressure also. Okay. So then TB, it refers to boiling point. If it is TF, it refers to which one? Freezing point. If it is the subscripts, we can have the three different subscripts that you have to opt for this. In sometimes I can use one or it may be the not. If that is the case, it is called as solvent. Which one? Solvent. If it is two or sometimes it may be the smallest that they are preferring, then we have to use that in the form of a solute. Suppose if there is no subscript, then it refers to which one? The solutions. So here TB or FB means it is the boiling point of the solution and this is the freezing point of the solution. Suppose if it is TB naught and TBF naught means BP of the given solvent and then the freezing point of the given solvent. Okay. Suppose if it is N2 means it is the number of moles of solute. Suppose if it is W1 means W1 refers to which one? Mass of the solvent, because 1 refers to solvent. If it is M2 for example, it is the molecular mass. If it is 2 means it is a solute. Okay. So in that way you have to be very well versed with respect to the symbols that has been strictly allotted for this particular session. That is preferably the solution chapter numericals. Okay. So that is about the main thing that you have to be very familiar before solving the numericals in case of this particular physical chapter, that is called as which one? The solutions. Okay. So now we will start some of the or solve some of the numericals related to this particular chapter, that is called as solutions now. Okay. So let us have the first one. The vapor pressure of the pure water at 50 degrees Celsius is found to be 12260 in terms of pascals. 18.2 grams of a solute was dissolved in 100 grams of water at the same temperature. The lowering of the vapor pressure produced is found to be 660 pascals. Already the direct answer is given. What is that? Lowering of vapor pressure itself is given. Then calculate the which mass, molecular mass of that particular solute. Okay. So let us solve this. Let's have the solution for this. So here first, the solute is what? And what is the solvent here? That you have to be very familiar first. The vapor pressure of pure water means it is a solution, solvent. Having a formula as usual, we know that it is H2O. 18.2 grams of a solute was dissolved. Means it doesn't have any name here. Means the solute is found to be what? Unknown. The name of that solute is not known because we have to find out that particular molecular mass of the solute. Okay, let us start now. The vapor pressure of the pure water, vapor pressure symbol as if I mentioned that it is in the form of capital P. Water means it is a solvent. Solvent means it is found to be the P naught, and that is found to be how much it is? 12260 in terms of pascals. The vapor pressure of the pure solvent that is called as water is found to be P naught, that is 12260. 18.2 grams of a solute means mass of a solute already is given. Mass means W. Solute means it is W2. W2 means it is mass of the solute. It is equal to how many grams here? 18.2 in terms of which one? Grams. It is dissolved in 100 grams of water. 100 grams of which one? Water. Means again it is the mass of water. Water means a solvent. Therefore, this W1 is equal to how many grams here? It is 100 grams at the same temperature. The lowering of vapor pressure. What's that? Lowering of which one? Vapor pressure. Lowering of vapor pressure, we know that it is delta P, which is also equal to P naught minus P, and it is directly given as 660 in terms of which one? Pascals. 660 in terms of which one? Pascals. The lowering of vapor pressure means it is called as delta P, or it is also equal to P naught minus P. Then calculate the molecular mass. Molecular means it is M. Of a solute means it is 2. Therefore, we have to find out this. As if I have given the list of formulas to calculate the molecular mass of a solute with the help of the 4 different colligative properties. Here the colligative property is what? Which is the colligative property here? It is the lowering of what pressure? Vapor pressure. If lowering of vapor pressure is given, how to calculate the molecular mass? First, we know that WKT means it is, we know that. Molecular mass of the solute is given by M2, and that M2 is equal to P naught divided by P naught minus P into W2 M1 divided by W1. This is the formula for calculation of which one? Molecular mass of the solute with the help of LVP. What is LVP? Lowering of what pressure? Vapor pressure. Just substitute, that's all. That's equal to. What is P naught that I have mentioned here? 122 how much? 60 into. What is W2? Mass of the solute is found to be 18.2 into. What is M1? M1 we have to know here. What is M? Molecular mass. 1 means solvent. Solvent means it is the water. What is the molecular mass of water? H is 1, 1 2s are 2, plus oxygen is 16. 16 plus 2, that is equal to 18. What 18 is? It is the molar mass or molecular mass of the solvent that is called as water. Therefore, M1 is equal to how much here? It is 18 divided by. What is P naught minus P? That is already given in the form of 660 into. What is W1? W1 is mass of a solvent that is called as water, that is equal to how many grams? That is equal to. So upon simplification, I will get the final answer in the form of 60.85. The unit with respect to this one is going to be gram per mole. Gram per mole. Gram per mole is nothing but the which mass? Molecular mass. Or if you just keep the number as it is, because molecular mass doesn't have any unit. Suppose if you want to put the unit, means don't mention that it is only the grams, because gram is not the unit with respect to which one? The molecular mass. It is the gram per mole we can refer. Or if it is just mentioned as only the grams, means it is called as gram molecular mass. That is why keep the number as it is if it is a molecular mass. Or If you want to express the unit with respect to molecular mass, it is gram. With respect to molar, it is simply called as gram per mole. Okay, so this is the first. We have calculated the molecular mass with the help of a which one qualitative property, that is called as lowering of what pressure? Vapor pressure. First, you have to know which is a solute and which is the solvent. As it is, the name of the solute is not given, therefore it is going to be the what? Unknown. That is having a solvent. It is pure water, means it is a solvent. Means the solvent is going to be the which one? Water. Okay. What are the given things here? The vapor pressure of pure water. What is the vapor pressure symbol that I have mentioned here? P, capital P. With pressure of solvent means it is a knot. Therefore it is called as what knot? P knot. And it is given as 122. How much? 60. Okay. 18.2 grams of a solute means the mass of the solute is given. Mass of a solute means it is W2. It is going to be the 18.2 grams. It is dissolved in how many grams of water? 100 grams of water. What water is? A solvent. Therefore, mass of the solvent or the water is given by symbol W1 is equal to how many grams? 100 grams. Then, the lowering of vapor pressure. The lowering of vapor pressure is directly given as delta P, that is equal to P naught minus P, that is mentioned as how much? 660 in terms of pascals. Okay. Then calculate the which mass? Molecular mass. Molecular mass means M, capital M. With solute means it is going to be the 2. Therefore, we have to find out the value of M2. Okay. And also we have to know the value of M1 itself, because as it's the solvent is a water means, because the solvent is water means what is the molecular mass of water? It is 18 grams or 18 grams per mole. Okay. And we have to know the formula. What is the formula for that? Using the help of lowering of vapor pressure, M2 is equal to how much? P naught divided by P naught minus P into W2 M1 divided by W1. So just substitute and forget the final answer. We are getting 60.85. Okay. So if you put the number, it is more than sufficient. Suppose if you want to express that in the form of a unit, means it is just called as what per what? Gram per. Okay, so that is about the first numerical based on the application with respect to the lowering of which one? Vapor pressure. Okay, let's move on to the second now. The vapor pressure of the pure water, again the same concept. What is that? The solvent is water. At 298 Kelvin is going to be 3.3 in terms of kilopascals, kPa. kPa means kilopascals. The relative lowering of vapor pressure of an aqueous solution containing, or calculate the relative lowering of vapor pressure of an aqueous solution containing how many grams of glucose? 20 grams of glucose dissolved in 90 grams of water at the same temperature. So now it is very clear. What is that? Solute is what and solvent is what? So here, he has given the solute in the form of which one? Glucose. What's that? Glucose. Glucose in water means water is a solvent, whereas glucose is a which one? Solute. What's the formula? C6H12O6. This is the formula for what? Glucose. C6H12O6. Okay. The vapor pressure of pure water. What is the vapor pressure? Again, symbol is going to be the P naught. What is that? 3.3 in terms of kilopascals, which is equal to 3300 in terms of pascals. Because as it is given in the form of which one? The kilopascals. Kilo means 10 to the power of 3. 10 to the power of 3 means it is 1000. 1000 into 3.3 it is equal to 3300 in terms of pascals. Okay. Calculate the relative lowering of vapor pressure. What do you have to find out? RLVP. What is RLVP? Relative lowering of vapor pressure is given by P naught minus P divided by P naught. That we have to find out. What is P naught minus P divided by P naught? It is called as relative lowering of which pressure? Vapor pressure. When aqueous solution containing how many grams of solute? 20 grams of glucose. Glucose means a solute. Solute means W2. It is equal to how many grams? 20 grams. It is dissolved in how many grams of water? 90 grams of water. Means mass of solvent or water is equal to how many grams? It is the 90 grams. Okay. So calculate the RLVP. That is the relative lowering of which pressure? Vapor pressure. Now, first we know that what is the formula to get the value of this? M2 is equal to what? P naught divided by P naught minus P into W2 M1 divided by W1. Or what actually I need? P naught minus P divided by P naught. What is that? P naught minus P divided by P naught. Therefore, what is P naught minus P divided by P naught is, it is called as RLVP. RLVP means relative lowering of which pressure? Vapor pressure. So what is that? If I put here, it becomes W2 M1 divided by M2 into W1. W2 divided M1 divided by M2 into W1. That is equal to, what is W2 here? W2 is given as how many grams? 20 grams into, what is M1? M1 means molecular mass of water. As usual, I mentioned that it is 80. Okay. So therefore, it is found to be the what? 80 divided by. What is M2? M2 means it is molecular mass of solute. Solute is what? C6H12O6. What is that called? Glucose. What is the molecular mass of glucose? Carbon is 12. 12 2s are 12 2s are 12 6s, sorry, plus hydrogen is 1 into 12 plus oxygen is 16 into 6. On simplification, I will get that as 180. What's 180? It's a molecular mass of a solute called as which one? Glucose. Therefore, it is found to be how much? 180 into. What is W1? Mass of the solvent. Mass of the solvent is found to be the. Okay. So I think 1s are 10s are here. 1s are 2s are here. 1s are 45s are. It is 1 by 45. What is 1 by 45? Upon simplification, I will get that in the form of 0.0 or 0 only. It is 0.022 only. What is 0.0222? It is the which one? RLVP. What is RLVP? Relative lowering of vapor pressure. What is the unit of this? It doesn't have any unit. Why? Because it is a ratio. P naught minus P is the unit of pressure. P naught is the unit of pressure. Pressure unit cancel means there is no unit with respect to which one? Relative lowering of vapor pressure. Okay. The same formula. There we have calculated in the first numerical. We have calculated the molecular mass of the solute. But here they have given the they have mentioned the calculation of which one? RLVP. What is RLVP? Relative lowering of which pressure? Vapor pressure. Okay. So that is about the numerical number 2. Okay. Next we will move on to the third one. The vapor pressure of pure benzene. The vapor pressure of which one? The pure benzene. The vapor pressure of the pure benzene at a certain temperature is how much? Is found to be 200 mm of mercury. 200 millimeter of which one? Mercury. At the what temperature? Same temperature. At the same temperature, the vapor pressure of the solution containing 2 grams of a non-volatile non-electrolyte solute in 78 grams of benzene is 195 millimeter of which one? Mercury. Calculate the molecular mass of the which one? Solute here. So here, which is the solvent or solute first? I think benzene is a solvent. Having a formula C6H6 because the vapor pressure of the pure benzene. Pure benzene means it is a liquid. Liquid means it is a pure solvent. Okay. And what is the solute here? What is the solute here? 2 grams of a non-volatile non-electrolyte means the name of that solute is not given. Therefore, it is found to be the unknown. The name of the solute is found to be the unknown. That is, solute is unknown. Okay. Let us start this. The vapor pressure of pure benzene. Vapor pressure means P with benzene means it is a solvent. Solvent means it is a knot. That is equal to how much? 200 millimeter of which one? Mercury. At the same temperature, the vapor pressure of the solution containing, at the same temperature, the vapor pressure of the solution containing how many grams? 2 grams of a non-volatile non-electrolyte. Means the mass of the solute is given. W2 is equal to how many grams? 2 grams. W2 is equal to 2 grams. In 78 grams of benzene, what benzene is? Solvent. Solvent means W1 is equal to 78. Mass of the solvent benzene is given as 78 and the mass of the solute which is found to be unknown is equal to how many grams? 2 grams. the vapor pressure of this solution, what is the vapor pressure of the solution means P is equal to, what is the P here? It is found to be the 195, I think. If this be the case, calculate the which mass? Molecular mass of the solute. What is the formula, symbol for the molecular mass of the solute? It is m of 2. Okay. So here, what is P naught minus P? Directly I will mention that. Can I say that it is 5 mm of Hg? Because 200 minus 195 is equal to what? 5. Okay. So that I will mention 200 minus 195, that is equal to 5 mm of which one? Mercury. Okay. So here what is M1? M means molecular mass. 1 means solvent. Solvent is benzene. Benzene is C6H6. Carbon is 12. 12 6 are 72. Hydrogen is 1. 1 6 are 6. That is equal to 78 grams per mole. What is 78 here? It is the molecular mass of the solvent. Which is the solvent here? It is found to be the benzene. Okay. Next, we know that. What we know that? M2 is equal to P naught divided by P naught minus P into W2 M1 divided by W1. Okay? That's equal to. What is P naught here? P naught is going to be 200 into W2 is 2 grams. M1 is 78, I think, divided by M1 is 78 divided by what is P naught minus P, that is 5 into what is W1? W1 is equal to 78. Therefore, I can cancel these two first. Okay. 1s are 40s, I think. 1s are 40s, 42s, I think. 80. 80 grams per mole. What is 80 grams per mole? It is the molecular mass or the molar mass of the non-volatile non-electrolyte. I don't know the name of that particular solute. It is just only given as what? Non-volatile non-electrolyte is going to be how many grams? 80 grams per which one? Mole. Okay. So that is about the third numerical with respect to the solutions. Okay. So let's have the fourth now. Next is the boiling point of benzene is found to be 353.23 in terms of Kelvin. When 1.8 grams of a non-volatile solute was dissolved in 90 grams of benzene, the BP is raised to 354.11 Kelvin. Calculate the molecular mass or the molar mass of the solute given Kb is equal to 2.52 Kelvin kg per mole. So first make it very clear, the pure benzene is a solvent here. Then the solute is non-volatile solute. Again it is found to be known or unknown here. It is an unknown solute. Unknown solute, sorry. Unknown? Benzene is a solvent. What is the solvent here? It is C6H6 called as what? Benzene. The BP of pure benzene, boiling point we have mentioned that is TB naught is equal to, what is TB naught? Boiling point of the pure solvent. Which is the solvent here? Benzene. It is found to be how much? 353.23 in terms of Kelvin. Okay. When how many grams here? 1.8 grams of a non-volatile solute. 1.8 grams. Means mass of a solute is given. What is mass of a solute? W2 is equal to 1.8 grams. 1.8 grams. Is dissolved in how many grams of benzene? 90 grams of benzene. Benzene is a solvent. Means what is the mass of the solvent here? W1 is equal to how many grams? 90 grams. The BP is raised to. So here if I add a solute to a solvent means it becomes a solution. Therefore the boiling point of the solution is raised to. What's the boiling point of the solution now? TB. How much it is? 354.11 in terms of which one? Kelvin. 354.11 in terms of Kelvin. Calculate the which mass? M2. What is M2 here? Molecular mass or molar mass of the solute. And also The molar elevation constant or boiling point constant, or it is also called as ebullioscopic constant, having a symbol of Kb directly given as 2.52 in terms of Kelvin kg per. What is Kb value here? It is 2.52 Kelvin kg per. Okay. So here what is delta Tb? It is actually Tb minus Tb naught. The difference in the boiling point of the solution and then the boiling point of the pure solvent is called as elevation of boiling point. Elevation of boiling point is given by delta Tb is equal to what minus what? Tb minus Tb naught. What's the difference of these two? 354.11 minus 353.23. So here if I simplify that, 353.23 means it is 0.77 difference. Here it is 0.11. 0.77 plus 0.1 means it is 0.88 in terms of Kelvin. What is it? 0.88 Kelvin here. It is elevation of which point? Boiling point. Then apply the formula. What is that? We know that. What's the formula here? M2 is equal to 1000 times the kbW2 divided by delta Tb into W1. What is this? This is an expression for the molecular mass of a which one? Solute. With the help of EBP. What is EBP here? It is the elevation of which point? Boiling point. M2 is equal to 1000 kbW2 divided by delta Tb into what one? W1. Okay, just substitute, that's all. 1000 into what is Kb value given? It is 2.5. Into what is W2? Mass of the solute. How much it is? 1.8. Divided by what is delta Tb? Difference. Difference is going to be 0. How much? 88 into what is W1? Mass of a solvent. Mass of a solvent is 9. Okay. So if I simplify with the help of calculator, I will get the direct answer in the form of 74.4. As it is a molecular mass means it is gram per mole. What is 74.4 here? It is the molar mass or the molecular mass of a non-volatile solute, because the name of that particular solute is not known here, because it is just given as a non-volatile solute. Okay, that is molecular mass of the solute M2 is equal to 74.4 in terms of gram per mole. So first you have to decide which is the solute and which is the solvent. According to that particular numericals, what is given here? The pure benzene means it is a solvent. Benzene is a solvent, and a non-volatile solute means a solute is unknown. Okay. The boiling point of the pure benzene means the boiling point of the solvent is having a symbol of Tb naught is equal to how much? 353.23 in terms of Kelvin. Then if I add how much of solute? 1.8 grams of a solute. Solute means it is W2. To how many grams of solvent? 90 grams of solvent. Solvent means it is a benzene. Therefore W1 is equal to 90 grams. By adding this amount of a solute, that is 1.8 grams of a solute to the 90 grams of a pure solvent called benzene, the boiling point of the solution rises to, what is the symbol with respect to boiling point of the solution? It is Tb. Tb is equal to 354.11 in terms of Kelvin. Okay. So here the difference of these two is called as elevation of boiling point, which is given by delta Tb is equal to Tb minus Tb naught, that is equal to 0.88 in terms of which one? Kelvin. Calculate the what mass? Molecular mass. Our molecular mass or molar mass is given by what? M2 is equal to, we have to find out. Then in addition to that, he has directly given the ebullioscopic constant, or it is also called as molar elevation constant or boiling point constant, which is also called as ebullioscopic constant. Kb is given by 2.52 in terms of Kelvin kg per mole. Okay. So then apply the formula. What is that formula here? M2 is equal to 1000 times the value of Kb into W2 divided by delta Tb into W1. On substitution and upon simplification with the help of calculator, I will get the final answer in the form of 74.1 in terms of, 74.4 in terms of gram per mole. Okay. So let's move on to the fifth one. 12.6 grams of a non-electrolyte, means it doesn't get ionized, is dissolved in 75 grams of water. It is very clear. It is dissolved in 75 grams of water means water is a solvent. having a formula H2O. Non-electrolyte means it is a known or unknown here. I can use the word as non-electrolyte, or indirectly it is going to be the unknown. The electrolyte is not known. Okay, sorry, non-electrolyte is not known. So 12.6 grams of a non-electrolyte is dissolved in 75 grams of water. So already it is given as non-electrolyte means W2 mass of a solute is going to be 12.6 in terms of which one? Grams. Mass of a solute. It is dissolved in how many grams of water? 75 grams of water. Water is a solvent. Therefore, W1 is equal to 75 grams, I think. The freezing point of this solution, freezing point of the solution here is given. TF is equal to, without subscript means it is a solution. What is that? 271.9 in terms of Kelvin. What is 271.9? It is the freezing point of that particular solution. How that solution is obtained? By dissolving 12.6 grams of a non-electrolyte in how many grams of water? 75 grams of the pure water. The freezing point gets lowered to an example of 271.9 in terms of Kelvin. If the molar depression constant means it is called as Kf. Molar elevation constant is called as Kb. Molar depression constant is called as Kf. What is that Kf value here? It is 1.86 Kelvin kg per which one? Mole. 1.86 Kelvin kg per mole. Calculate the what mass? Molecular mass of the solute. M2 we have to find out. M2. Given the freezing point of pure water, what is the symbol for pure water called as solvent? TF naught is given. What is that? 273.15 in terms of Kelvin. Means the freezing point of the pure water is given, freezing point of the solution is already given. Then what is delta TF here? It is TF naught minus TF. In the previous what I mentioned, delta TB is what? TB minus TB naught. It is solution minus solvent. But as it is a depression means it is the solvent minus solution. What's the difference of those two here? TF naught minus TF. So there it is 1.1 I think. 1.1 plus 1.25 I think. 1.25 is nothing but a what? 1.25. 1.25 in terms of Kelvin. What is 1.25? It's a depression in which point? Freezing point. Okay. So calculate the which mass here? Molecular mass. What's the formula? We know that. What is M2 is equal to 1000 Kf W2 divided by delta Tf into W1. 1000 Kf into W2 divided by delta Tf into W1. That is equal to 1000 into what is Kf? 1.86 into what is W2? Mass of a solute 12.6. What is delta Tf? Delta Tf is 1.25 into W1 mass of the solvent. Solvent is going to be the 75 grams. So upon simplification with respect to the fifth numerical, I am getting the value in the form of 249.98. As it is a molecular mass means it is called as gram per. Again the same thing. Instead of boiling point, he has mentioned the what? Freezing point. Here, the freezing point of the pure water that is a solvent is going to be 273.15. Usually 0 degrees Celsius, we are calling that as 273 Kelvin. It is exactly given as 273.15 in terms of Kelvin. Then, by adding how much of solute? 12.6 grams of a non-electrolyte solute into a 75 grams of pure solvent that is called as water. The freezing point of that solution decreases from 273.15 to 271.9 in terms of Kelvin. On that basis, I have mentioned that delta Tf or the depression in freezing point is given by Tf naught minus Tf, which is equal to 1.25 in terms of Kelvin. Okay. Then the molar depression constant is going to be Kf is given as 1.86 in terms of Kelvin kg per mole. If this be the case, what is the calculation here? Molecular mass. How do you get the molecular mass here? Molecular mass of solute M2 is given by 1000 times the Kf into W2 divided by delta Tf into W1. So upon simplification, we are getting the final answer as 250 nearly 249.98 in terms of gram per mole. Okay. So let's move on to the sixth. Let's move on to the now, next one is 20 grams of an organic acid is dissolved in 500 grams of water. Already it is given. Organic acid is a solute and water is a solvent. That's the difference here. Means solvent is water and the solute is the name of that one is not known, but it is given as what acid? Organic acid. I don't know what is the name of that acid. How many grams of organic acid that I have dissolved here? Mass of acid or solute is equal to how many grams? 20 grams. It is dissolved in how many grams of water? W1 is equal to 500 grams of water. The depression in freezing point of water was found to be by 1 degree. Means already it is given. What is that? The depression in freezing point is given by delta TF is equal to 1 in terms of degree Celsius or degree Kelvin. Only 1 degree, okay, mentioned as. Means directly the TF is, delta TF is given, that is equal to how much? 1. Calculate the which mass? Molecular mass of the solute. Molecular mass of the solute. If Kf is given as how much it is? Molar depression constant is 1.86 Kelvin kg per which one? Mole. I think the same one. We know that. What's the formula here first? M2 is equal to 1000 kf W2 divided by delta TF into W1. Delta TF into W1. That is equal to 1000 times the what is the Kf here? 1.86 I think into W2 mass of the solute. Mass of the solute is how many grams? 20 grams divided by delta TF is 1 into W1 mass of the solvent is going to be 500. I think ones are twos are here. 3.76 means 7 point something, nearly 74.4 here. As M2 means it is again what per watt? Gram per watt. What is 74.4 here? It is the molecular mass of a organic acid which is acting as a what here? A solute. Means a solute is an organic acid and a solvent is a pure water. How many grams of acid that we have added here? 20 grams of an organic acid is dissolved in how many grams of water? 500 grams of water. Means W1 is equal to 20 grams and W2 is equal to 20 grams and W1 is equal to 500 grams. If this be the case, the depression in the freezing point is found to be what? 1 degree. Means directly the delta TF is given as how much? 1. Okay. If this be the case, we have to calculate the what mass? Molecular mass. And also he has given the value of Kf. What is Kf here? Either molar depression constant or freezing point constant, or it is sometimes referred as which one? The cryoscopic constant. We are having 3 different names with respect to Kf. What is that? Molar depression constant or freezing point constant, or it is also called as cryoscopic constant. That Kf is given by 1.86 Kelvin kg per mole. Then apply the formula. What is the formula here? Molecular mass of the solute M2 is equal to what? 1000 times the Kf W2 divided by delta TF into W1. On substitution and simplification, I will get the final answer in the form of 74.4 in terms of which one? The Kelvin. Okay. So this is about the first part only, or the first session of numericals with respect to a chapter called as which one? The solutions. Okay. So in the next session, we will continue the same thing with a different colligative property, or it may be the application of Raoult's law and then the which law here? The Henry's law. Okay. So that we will discuss in the next session. So thank you.